Same thing. Hello, folks. First thing, I want to apologize to you. If you folks have seen my talks before, you know that generally I leave a lot of time at the end of talks for questions. I don't have that time this time. Please hold your questions till the end. I probably won't actually be able to get to them, but you can bug me in the hallway, or there's plenty of other folks who know Perl 6 really, really well. For the people who don't know me, Curtis Poe generally knows Ovid on the net. Allaroundtheworld.fr. We're based in France. That's my company. We do bespoke software development, usually in Perl. We also do training in Perl, databases, Git. And today's talk is a dynamic language for mere mortals, Perl 6, with the unwitting assistance of one Manuel Cerrone. Manuel, are you here? He's actually a Pythonista, so he looks down on all of us. I just want you to know that. But thank you very much for your comments, which helped. So, if you wanted to learn how to drive a car, you might be interested in a car, maybe you don't know much about them. I have a couple of friends of mine who are race car drivers, and you can ask them about this. And they could tell you what that spring does, what that nut does, what that thing does. They can tell you all this stuff about engines, about fuel oil ratios, about gear ratios, about how brakes work, and about all these things that by the time you're done, you might be intimidated as heck by this and say, I don't want to have anything to do with cars. This is scary. But the reality is, most of us know we just get in a car and drive. It's simple. We don't have to look under the hood. And I've heard three primary complaints about Perl 6. A, the length of time. Can't do much about that. B, the version number. Can't do much about that. C, the complexity. That's interesting. There's a lot of very complex languages out there, such as Perl 5, C++, etc. The reality is most of what we do on a day-to-day basis, it's pretty easy in Perl 6. And you'll understand some of that by the time we're done. But first, basic math. This is almost like a lightning talk before the actual talk, something very frustrating to me, because basic math, can anyone solve for x? Oh, come on. Okay, forget about computers. Forget about computers. What is the value of x in this equation? What would your teacher have graded you on? Ah! Okay, so since you folks are a little slow, x is 3.5. We know that. We know that. Ruby doesn't think so. Python 2 doesn't think so. Tickle doesn't think so. BC is a wonderful tool. It's an arbitrary precision calculator built into many systems, and it says 3. So there's a bunch of one-liners I wrote to demonstrate this issue. In fact, I wrote a one-liner in C. And in fact, here, we actually get a warning about this, but no, C's type system sucks. C does not give us a warning. The compiler gives us a warning because, well, %f in the format, that says double, but it expected an int. What's up with that? We switch that. OK, fine. We got the 3 again. Purpose of software is to help humans. It is not to help computers. I've actually argued with people. They've told me, no, 3 is the correct answer because integer operand integer gives an integer. No, it does not. We know it does not. So always keep that in mind when you're thinking about software. Stop forgetting about what the computer does. Stop thinking about the limitations of the computer. Think about, what do I need as a human in order to solve my problems? And then sometimes the implementations are going to bite you, and that's frustrating. We'll actually see an example of that later. But software is there to help humans. Forget about integer math. So we know Perl 5 actually gets the right answer in this case. So you know 7 divided by 2 in integer math gives you 3. What does negative 7 divided by 2 give you? If you know the answer, don't call it out. If you don't know the answer, use your intuition. What should it give you? Minus 3. Minus 4. So who here thinks minus 3 for integer math? Who here thinks minus 4 for integer math? A few more hands. OK, so C, Yeah, -3. So all of you said -4 were wrong. What do these other languages all say? Well, Perl, we know, gets it right, Perl 5. And they say -4, -4, -4, -3. So a room of very smart, intelligent people with a not difficult math problem were not able to reason what sort of answer they would get. So this is a junction. Yes, it's a superposition of. So by the way, so C said -3, except it's not that simple, because if you're using C89, the wrong answer that you get is implementation dependent. So you can have a perfectly correct program in C89, ship it off to someone else, and it will fail for them just because they happen to use a different compiler. Frustrating, to put it mildly. Let's do it again. First of all, does this look difficult for anyone? Okay, 0.1 plus 0.2 is 0.3, minus 0.3 is 0, x equals 0, 0 equals 0.1 plus 0.2 minus 0.3. Forget about computers. Would your teachers in maths class have said this is correct? Yeah. What does Perl think about this? That's a very small number. But it's it's not a small number in one sense, because if you think about it in terms of math, there's infinite in number theory. There's infinite many numbers between that and 0. In fact, in terms of something called Aleph null, there's as many numbers between that and 0 as there are between 18 quadrillion and 0. 0, we know, has special properties. So 1 divided by 0 is 18 quadrillion. That is an exceptional number. That is not an exception. Or let's multiply the mass of the sun by 0. That's 110 trillion kilograms, or as Enrico Fermi would tell us, roughly the size of Mount Everest. Yes, as all of you have suspected, Mount Everest is nothing more than a floating point error. And other languages tend not to do any better, you know, Ruby, Python 2, Tickle, BC. BC actually gets this right, but considering that it can't figure out 7 divided by 3, you know, it's not very reassuring. And Perl 6 says 0. If you're wondering what's going on, it's like, ooh, he just pulled a rabbit out of a hat. So floating point numbers, basically, the way this is typically done in computers is they estimate the number that comes after the decimal point. You have reciprocal powers of 2, which wind up getting added up, the 1, 0, 0, 1, etc., to estimate what that number should be, to approximate what that number should be. And there's many things you can't get exact, which is why 0.1 plus 0.2 minus 0.3 can't quite add up to 0 in floating point math. Perl 6 gets it right. How does it do this? I talked about the engine looking under the hood. Most of the time in this talk, I don't want to look under the hood. But this time, just to give you a little peek of what's going on. So here we've got divide by 0, which is, you know, we've got an exception, exactly what we want. If you just type Perl 6 at the command prompt, hit return, you're dropped into a simple REPL. Perl 6, everything's an object, so you can call methods on them. There is the what method, which says it's a rat. It's actually, that means it's a rational number. There's a role called rational, which is why they can't call it a rat. So it has a numerator, 3, a denominator, 10. Nude is a method on rational numbers, which returns a list of the numerator and denominator. Perl is just basically a serialization. It says, you know, it's kind of like data dumper, sort of. But it prints it out in a format that hopefully can be serializable. What's interesting is down at the bottom, that's 3.1415927 is sort of pi. And the reason I say it's sort of pi is because we know pi is an irrational number. But now, instead of letting the vagaries of floating point mathematics choose how inexact it is, you can choose how inexact it is. So we're going to forget about that, because most of the time, you just do your math and it's going to work for you. It's going to work nice and cleanly. The errors you see on Stack Overflow, why didn't this work? Why couldn't I compare those floating point numbers? Why couldn't I divide these and, you know, get the right answer? All tiny little things like that, gone. Not all the time, but Perl 6 tries really, really hard to be a language for humans, not for computers. But instead, I'm going to talk about functions. Yes, reciprocal is a stupid function. This is someone who got really carried away with the idea of don't repeat yourself. But the reason I'm going to talk about functions is one of the most common classes of errors we have in computer programming languages today is that different pieces of your program have to talk to each other, which means generally you have to pass data back and forth. And you can unit test everything to death, but if you don't integration test, if you don't test how things talk to one another, you're going to find all sorts of bugs. But you can't test exactly how everything talks to each other all the time because you've got the path problem, etc. So it's really nice if you have good control over what you're actually getting in there. So if you're not familiar with Perl 5, you might wonder what this shift is. And then you might really wonder what this $_0 or this, this num equals shift, or, why do we have to use parentheses there? That's embarrassing. So you can write something analogous to all of those in Perl 6. We don't want to do that. That's really embarrassing. But before we talk about functions, not everyone likes the Fibonacci sequence as an example. Oh, this doesn't map to the real world, even though it really, really does. But I won't go into that. Why do we often use Fibonacci function when we are teaching people recursion, teaching people how basic functions work? They're very, very easy to map to the mathematical description of what the Fibonacci function is. So it's very easy to show them that way. It's easy to show the elegance of recursion with them. It's also very, very easy to understand them. It's very easy to describe them. And what problems do you have with recursive functions? You might forget the base cases. Very common problem. That's a human problem. You might not validate your arguments well. That's a very common problem. That's a human problem. You might blow the stack via deep recursion. That's a very common computer problem. So you have all sorts of failure modes, which this incredibly simple thing can examine in a simple function, which is why I like to use the Fibonacci series. And it's simple. So 0, 1, you start with that, add those together, you get 1, then 1 plus 1 is 2, add that, append that, 1 plus 2, 3, etc. This is the Fibonacci series, which has fascinating mathematical properties I won't go into right now. Logarithmic spiral of our galaxy is based upon Fibonacci spiral, by the way. So all sorts of neat stuff about that. And to write it, got a basic function signature, nth. The nth Fibonacci number, in this case, we're indexing from 0. So that's actually 9th. So given nth, when 0, 0, when 1, 1. This is like Perl, the last statement evaluated, or expression, whatever. When I say statement or expression evaluated, returns, yeah, whatever. The last thing you evaluate returns the number, returns its value as what you're supposed to get back. And here, fib nth minus 1 plus fib nth minus 2, this is almost exactly the mathematical definition of Fibonacci numbers. Really simple, really easy. And aside from that simple signature right there, that's how we'd write that in Perl 5. And in fact, if you use modern Perl, like 520, use the experimental signatures. Signatures have been around before most of us were born. Use experimental signatures, use the given when statement in there. It would be almost exactly the same. Might actually be exactly the same. Yeah, you'd need the parens there. So say fib 8 works. But now we have an infinite loop. We remembered our base cases of win 0 and win 1. But 3.7, well, that's not going to work because nth minus 1 and nth minus 2 will never hit our base cases. That's kind of unfortunate. So we've got an infinite loop. It means we have to have an integer for nth. And how would we do this in Perl 5? So this actually has a bug. This actually has a bug. This actually has a bug. Every single one of those is buggy, and there's plenty of other ways you can write that, and most of those ways are going to have bugs. And it's such a pain to do that many developers they do what we do in dynamic languages. We say, we're going to hope we got the right data, and most of the time it works. And when it doesn't work, we have to figure out where that wrong data came from, and we hope that it fails rather than just silently corrupting our data. It's a pain. So all of those are actually buggy in different ways. And now we just slap an int on there. And we say it's an integer. And now this becomes a runtime failure. Not true. I'll explain in a moment. So adding the int is what we call gradual typing in Perl 6. They're strictly optional. If you don't want to use them, don't. If you do want to use them, put it on there, and it's nice. That will be a runtime failure in Perl 6, except in this particular case. So win 0, 0, how does it know what win 0 means? Internally, as I understand it, what happens is it calls the .what method on 0, says it's an int, which must have the value of 0. So you could actually supply a subclass of int, and I imagine it should still work. And then for 1, it does the same thing, calls .what, figures out it's an int which must have the value of 1, so it knows to call this 1 or here. Here, when it checks this, because this is hard-coded, it's going to call .what on 3.7. It's going to see the signature can't possibly match an int. This is actually a compile time failure. That code, it's not possible to run this code. It doesn't make any sense. You can't do it. So Perl's going to say no. This is what we call type inference. A magical thing. It's a magical thing, but it's simple. But it's still not there because now we can call -3. So -3 is going to be an infinite loop because the -1 and the -2 are never going to hit our base cases. So we just get a subset. Constraint type check failed for parameter nth fib -3. So what is this? Where star? The asterisk is an example of the whatever class. And I like to read that generally as whatever I got. Int nth where whatever I got greater than or equal to 0. You can't pass in a negative value because you'll get a constraint type failure. But, you know, this is actually getting kind of clunky here. Int nth where whatever I got greater than or equal to 0. What if you have multiple parameters being passed to this sub? That's going to be frustrating. So you pull it out into a subset. Subset non-negative int of int where whatever I got greater than 0, greater than or equal to 0. And then we just declare this as a non-negative int nth. In other words, basically declare your own types on the fly with an easy-to-read syntax and use them where you need them. Does this look like rocket science to anyone? Does this look to anyone in this room like it's so mind-bendingly complicated that it's just not going to fly? It is a bit. I'm ramping up, but honestly, Perl 6 is a new language. It is a sister language to Perl 5, the way C# is a sister language to Java. And I mean that in terms of also quality. That's really not hard. You do have to learn how to read a new language, but that's simple. And then we get the constraint type failure. So signatures. For popular dynamic languages, I'll just call those dynamic languages after this. You know, mainly we're talking about Ruby, Python, JavaScript, whatever. You get maybe, depending upon the language, 1 through 4. Optional, entirely optional. Basic ones, you just name the variable default. If you don't pass in foo, it'll have the value of 3. Named variables, you put a colon in front of that, and then you call it by name. You know, name, arrow, value. Or there's another syntax for that, which I won't go into right now. Gradual typing, we can slap a Boolean on there. And that's got to be a Boolean value you type in, or else boom, you pass in or boom. And then sub-constraint string name where whatever we got, cars greater than 0. So the last two generally aren't available in the popular dynamic languages. But they're really easy in Perl 6 and optional. The last one, I really like that last one. That this particular constraint, subset non-empty string of string where whatever we got, cars greater than 0. I hate all the time expecting to get a string, and I have to check to see if it's an empty string. Here, I'm just writing my own type on the fly, saying this better not be an empty string, and I just declare it there. I don't have to write a class. I don't have to jump through any hoops. I don't have to remember to check anymore. Do I actually have data in this string? And this is a common problem across many programming languages, not just the dynamic ones. And I know dynamic, static, rather loose, but bear with me on that. So I also think, by the way, this I think will be the most popular subset declared in Perl 6, some variant of this to make sure you're getting non-empty strings. But I like this one, subset first name of string where 0 is less than whatever we got, cars, less than 256, sub first name, blah. That, I suspect, will be very popular in ORMs, where you need to map your types directly to the constraints the database will allow. So if you have MySQL and you're not in strict mode or better, and it has this nasty habit of truncating your data, don't worry, Perl 6 will protect you. I love MySQL. If you do any consulting on that, it is a license to print money, I swear. But it's slow. You start hitting Fibonacci numbers in the 20s and on up, particularly like 25. This really slows down to the point where it becomes unusable because we're blowing the stack with deep recursion. I'm not going to walk through the recursion graph. I assume most of you are familiar with it. If you're not, I apologize. But basically, we keep recalculating the same values over and over. One of the ways to deal with that is we cache the values. So a state variable will return its values in between subcalls. So we just have this cached state variable. Unless cached nth exists, this colon exists is an adverb in Perl 6. Again, different language. You're going to have to learn some new syntax here. Unless cached nth exists, win0, 0, win1, 1. Default cached nth is blah, and then we return the cached value. That's not too hard here, but if you start having larger recursive functions, that gets to be a little bit annoying, having to go through there and instrument everything to handle your caching. But every recursive function can be rewritten as an iterative function if you wanted to skip the caching. But now we started to lose the mathematical beauty of what we had in that. And that's now you can't just glance at that and say, oh, that works. You now have to do a desk check or write a bunch of tests to say, is that actually doing what I wanted it to do? Because it's not the same structure anymore. Because remember, that was your mathematical structure that you had, and this is the body of the recursive sub. Those map really well together. It's very easy to follow. You want to keep that. So just slap an is-cache trait on there, and it will handle the caching for you. You generally want to do pure functions. Given this value, it's guaranteed to return the same value every time. Doesn't have side effects. You probably won't want to do that with a get customer method, because the get customer the customer might mutate in the meantime, or anything which will change or has a lot of disk I/O. But for pure functions, just slap is cached on there. It's an example of Perl 6 taking a very common problem that we face all the time and just building it into the language to say, here's a feature for you that you can use. Try not to cut yourself with it. So first of all, is everyone with me so far? Yeah, this is not hard stuff. Most of this is basic. I'm just showing you how Perl 6 does it. So a lot of you folks know that I'm writing a text-based MMORPG in Perl. And characters can travel to other areas of a space station. They can travel to other space stations. They can travel to other stars via wormhole jump gates. And this is my character travel to method. We're going to start moving into a little bit of OO Perl. By the way, how am I doing on time? More than 15? Oh, I'm doing better than I thought. Great. So this is actually my dispatching for, if location is a station area, travel to station area. If location is a station, well, this is kind of a simplified version. But that comment, my kingdom for MMD, that is verbatim from my code. This is, as I add more location types that you can go to, having a bigger if-else-if chain, very frustrating. I could do this. I could slap a role on our locations. If you're not familiar with roles, I apologize. I could slap a role on location and say if location does location, and location travel to character. This is unfortunate because now I'm using object-verb-subject syntax instead of subject-verb-object, which makes this harder to actually understand. So I might say location traveled to by character when you have to contort yourself on method names. That's a code smell. And in this case, the code smell is I don't think location should know about characters. I'm coupling them too tightly. Location don't have to know anything about the characters traveling in them. I'm distributing the character knowledge too far. But characters do have to know about the locations they are traveling to. So I want the characters to have that knowledge. Reduce the coupling. And in Perl 6, I would just do this. Multi-method travel to station area, station, star. Very simple. Many programming languages have this today. Here we're dispatching on type. Perl 6 will say what types of arguments do we have, and it will dispatch for you accordingly. It makes your code much simpler. And you don't have to worry about missing the case of, you can't travel to this location because we didn't find a type for it. Perl 6 will blow up for you. By the way, here's Fibonacci again. You could have written this as multi-subs, fib0, fib1, multi-sub fib. I should have had an is-cache trait in there, but I wanted this to fit on the slide. So more than one way to do it, obviously. Return types. That's another one, very useful. So subfoo returns bool. What does some other sub return? In looking at this code, you cannot tell. It is not possible to tell just from this one line of code. But what you know, looking at this return type, is if this returns anything other than a bool, this is going to blow up. So here, say yes a foo, yes is the desired behavior. If we tried to return a string, type check failed for return value, expected. That's pretty easy. We're going to be writing functions all the time, and one of the most common classes of errors, passing data around, much easier to constrain the values and get the right thing. So for that some other sub, you know, if you went and you inspected that and say, yes, some other sub does indeed return bool, as I was guaranteed, and some other developer comes along later and decides in this condition I'm going to return a string, maybe an error message, your code will blow up as expected to protect you from having bad data. And of course, you can use the subsets that you defined earlier. Sub foo returns non-negative integer. You can have very complicated types you're declaring on the fly and just assert them all over the place to make sure that you're not getting bad data passed around. You don't have to keep writing that validation code all over the place, or as I usually see with most of my clients, they just don't bother to write the validation code and kind of hope it works. Now I talked about methods a little bit. Now we're going to look at classes. Classes are where it's really going to be strange for you at times because some of the syntax will look a bit odd. Again, new language. But it's really impressive what you can do with them. And the choice of a point class might be a little controversial for those who are familiar with OO programming. This is not designed to show you OO programming. This is designed to show you some features of Perl 6. So just keep that in mind. Class point has $.x. This point is kind of that's the secondary character's punctuation mark is called a twidgel in Perl 6. And the point just kind of helps you remember, because we call methods with points, that's a attribute for that class. So it has point x0, has $.y equals 0. The equals 0 is the default value if you don't pass that into the constructor. And the $.x, this is what the instance value, this is the instance variable you're going to have. Here's string overloading, method string, and I just return in brackets $.x, $.y, my point new x, y, say point x5, say point y3, and say point in, in quotes for the string overloading, you got 5.3. So that's okay, so that, dollar point, that extra punctuation mark might look a little bit strange, but it's very Perlish. Doesn't look too difficult, I would think. This is an immutable point object. You can declare it, you cannot change it. Maybe we want to change it. Here's the point where it's going to start looking a little funky. So remember, the colon in front of the variable means that this is a named variable. So, y3, but we'll be using this on the set method down here. And the equals, the $.y, means if we don't pass it in, this is going to be the default value. So down here, we did not pass in x, so it's going to retain $.x. So if we don't pass in x to the set method, it's going to retain whatever its value was. So we can use set to set either x or y. Now, what the heck is that? $bang x, $bang y. Perl 6 likes to make a lot of things immutable. There's a lot of benefits to this. There's a lot of safety to this. Won't go into this right now, but basically, if you want to change these, by default, these are read-only attributes. So you can expose them, people can read them, you cannot change them. To change them, use the internal form, which has the bang, which is like, danger, Will Robinson, danger. You're changing the internals of this, but now you can do this. So basically, this set method will let you set x and or y, and you can say, point down here, we see 517, this actually worked appropriately. So the syntax, take you a bit to get used to it. It's really not hard once you understand what's actually going on. But you can actually set y to foo. So we already know about gradual typing in Perl 6. So just declare y as a real if you want to. Now if you try and set y to foo, boom, it'll blow up. No extra work for validation. It works as you expect it to work. But I'm now declaring those as read-write and getting rid of that set method, because the reality is the Cartesian plane, the x and y values can be any of infinite values depending upon what your computer can actually support. And now, since we know it can be any real value whatsoever, why not let people set it directly to real values? And you can say point.y equals 17.3, and it works. We've now exposed the attributes. We've got a little bit of type safety there. So some of the languages they recommend you don't expose these values, but remember, you can declare subsets to get much, much finer grained control over what you allow. So it's easier to expose stuff if you want to. Again, I'm not saying this is a perfect example. It's just showing you some of the power of what we have here. So I might say x and y can only be from -10 to 10. So subset point limit of real where -10 less than or equal to whatever we got, less than or equal to 10, then has point limit. And now if I set that to now if I set that to 17.3, it again blows up as we expect. So I'm gradually building all of this stuff up. So we'll get to the conclusion in just a moment. Does anyone have any questions at this point? I think we've got the time for it. I'm sorry, that means it's read write now. My apologies, I probably glossed over that too fast. Attributes in Perl 6 by default are read only for safety. And also I believe there's some performance benefits to that. Here, we're deliberately saying it's read write, so you can go ahead and try and set the value, even though we've set the value to an illegal value. And then we've got the defaults of equals 0. But those defaults don't make sense. Why should a point object start at the origin? So we can now simply say equals $.x is required or $.y is required. This actually generates a closure. It's not evaluated at the time this equals. So this will only be evaluated if you didn't pass in a value for x or y. So now we've made these required. You cannot instantiate an invalid object. And we can't set it to an invalid value. But here I'm doing -10, .10. The dot's a range operator. Perl 6 is smart enough to realize subset point limit of real where -10 to 10 means the same thing as that version. So that's another way of writing that constraint. Or, if I wanted to get kind of silly here, I could drop the of real and say -10.0 to 10.0. I didn't say subset point limit of what. Perl looks at the point 0, looks at the hard-coded constants, and uses those to figure out what type we have, type inference. Yes? Yes, that's going to be a rat. I've already tested it. It does effectively behave the way you want it to. That was something I was hoping to not go into to discuss the differences between real and rat here. In reality, I probably would not do this. I'm just trying to show people some of what's available on this. I would probably be a little bit more explicit and use the of real until I start feeling more comfortable with what's going on. I'll try and get to your question afterwards because I want to make sure. How am I doing for time, actually? 15 minutes. Okay, what's your question? No, sometimes they're enforced to compile time. It's Perl, it's a late binding language. But there are times when Perl can detect where something cannot work. If you have a hard-coded constant, 3.7, and you try and pass it to a function which only accepts an int, it will know this at compile time. Correct me if I'm wrong, but it's my understanding that there's possible plans of doing more with type inference in the future, but the concerns are making it so that we have human-readable error messages. Is this correct?
That's part of it. The basic problem with type inference is if they get too much smarter than the user has to be as smart as the type inferencer to figure out what went wrong.
Yes.
So we're a little...
So, yes, they're being cautious about it because it is problematic, but the power, the potential is there. So I showed the -10 to 10. So here, notice that here, I'm getting rid of the string method. I don't like this string overloading. So instead, I'm just going to say point Perl, and I get the serialized version, point new x5, y7.2. Now let's stop just for a moment and think about what we have here. Ignoring the class declaration, I have 3 lines of code. They're actually pretty easy lines of code to read. I've declared basically a new type with constraints on the fly. I've declared the 2 attributes for the class. I've made them mutable, and I've made them required. They have to have default values. Does this look really hard to read? Given the fact that it's a brand new language, that is not Perl, not Perl 5. Does this look hard to read? 3 lines of code. Here it is in Core Perl 5. That's effectively the same thing in Core Perl 5. Those 3 lines of code. But we know we don't use Core Perl 5 objects anymore, so there's Moose. So Moose is still a little bit more painful. Oh, there's C++. There's Java. There's Python 3. What's that? No, that legitimately was Java on that one. So Python 3. Can't really declare a type, so there's a class up there to simulate that. There's JavaScript. Ruby. My favorite was Go. I had to shrink the font size in order to get this to fit on the darn slide. Because Go, it may be a wonderful language, but oh my goodness, it's verbose. Look at that. That is very powerful, very expressive, and it's simple. It's really not that hard. It's a new language. It's like, if you don't know how to speak French, you're going to have trouble speaking French. I speak French, but not fluently, so occasionally I struggle when I read it, but I'm getting better. That's what happens with a new programming language. But nothing I've shown you is hard, and one of the most painful classes of problems of passing data around is made so much simpler in Perl 6. So, oh, love that example. So for your day-to-day code, it is more correct, and it's safer. You can actually enforce constraints easily on how you're passing data to and from functions all the time. This is part of the reason, incidentally, why a lot of static languages, I use the term loosely, there's a lot of tests that they often won't write, because they know they don't have to test what happens if that function receives a string instead of an int, because it's not allowed to. So there's a lot of declarative stuff you can bake in there, and there are fewer tests you'll have to write. So Perl 6, it really is large. There's no question about that. A lot of people know about that. Well, it is a large language. So is Perl 5, so is C++, so many others. But the common features that we often need on a day-to-day basis, particularly the things we fall down on, they're baked into the language. They're there for you. It has proper OO. I wish I could have dug into that a lot more, but we only have so much time. It actually is easy to read. Most of those examples, once you understand what's going on, they're not hard at all. And as I mentioned, it's safer. It's very powerful. There's all sorts of resources. Here's just a few of them. I was amazed when I was writing this, hitting a Freenode, talking to Perl 6 folks, just how helpful they are in saying, this is what's actually going on. These are the things you can do. It was a wonderful experience. I thought I was going to be bugging them too much. They're like, no, we'd love to talk about this. I do have bonus slides. I could whip through real fast, or I could take a couple of questions. Bonus slides or questions? Every time I ask that question, people always pick slides, you fools. So this is the part which tends to scare people. This is an infinite lazy list of, we're going to get all prime numbers from 1 to whatever, basically infinity. And we're going to assign it to this constant primes. We can declare constants. It's going to be immutable. So say all the primes up to 10. We get all the first 10 prime numbers. And Perl 6 tries very hard to make sure all your lists are lazy. There's all sorts of benefits to that. Make sure your lists are lazy when appropriate. If we don't have an invocant in front of the dot, it calls it on the topic, $_. So that's what's happening with this. And the first 10 primes are calculated. The rest will not be calculated unless needed. So if you're iterating over the infinite list of primes until you're looking for a prime which fits your property, you can declare it like this, and then it'll just break out when you need it to. So lazy lists are very handy, but constant, having that sigil in front's kind of ugly, so you can go ahead and drop that if you want to. Here's a comment. How much time do I have left? Oh, awesome. So here's a problem. This actually happened to me when I was a junior programmer. It was kind of embarrassing. So, writing a simple filter, and we just want to print the lines from a file matching stuff. So this junior programmer, like me, the idiot, writes a little 8-line file, runs it through here, works great. and then hits that 45 gigabyte file in production and it bombs. Can anyone tell me why? For each, what? What is special about for each? Yes, it slurps. Slurps all of it in. So in Perl 6, my file handle equals open file. There's other ways you can write this being Perl, but this is lazy. You can go ahead and read that huge file because this is automatically lazy. So many times the distinction between while and for kind of goes away. So in Perl 5, for reads in lists, which automatically flatten. While tends to use iterators. Here, just, that's lazy. Say line, if line, smart match, whatever, a regular expression. Or, we can write it a little more compact. We can just filter it directly, not even worry about the rest, line, and then just say the line. So lazy lists, they're just a wonderful thing. The Fibonacci numbers you saw earlier. Yeah, this is the part that hurts people. So now we have 3 dots instead of 2. That's a sequence generator, is that the name? Sequence operator. Instead of a range operator, it's a sequence operator, and it knows how to generate a sequence of numbers. We'll explain what the heck this means in just a moment, saying Fibonacci is up to num. Again, lazily calculate the Fibonacci sequence. Yeah, what the heck is that? Whatever we got plus whatever we got, dot, 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 whatever. So, sequence operator. This is an arithmetic sequence. If we have 2 numbers there, then it's going to say it's an arithmetic sequence, and it will be able to figure out how to lazily calculate that. Say the first 10 numbers of this arithmetic sequence, 0, 2, 4, 6. Did I get too many? No. So that's pretty simple. So does this kind of make sense? 0, 2, we're going to generate a sequence up to whatever we happen to need. It looks strange, but it works, and it's lazy. So it won't calculate that off to infinity. But if you have 3 numbers up front, this is a geometric sequence. And Perl 6 will figure out what you need there. So 2, 4, 8, dot, 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 up to whatever we need. We say in our sequence up to the first 10 numbers, 2, 4, 8, blah, up to 10, 24. Anyone recognize that geometric sequence? Yeah, it comes in kind of handy sometimes. That was awful. But sometimes the sequences we need, like Fibonacci, are a little bit more complicated than this. So we can do something like this. We have this arrow. What is this arrow? We have A, B, A plus B, sequence generator. So this is a pointy block. This starts a sub. Here are the parameters the sub's going to take, A plus B. So it knows the first 2 things you had before it in the list are going to be added together to generate the next item. And then you'd have the 1 and the 1 added together, generate the next item, which is a 2. Then you add the 1 and the 2 added together, generate the next item. This is how you generate a complex sequence. If it has, this regular format, you might notice this pointy block. Isn't that what we saw after a for declaration? That's the exact same syntax as what you have in the for. Perl reuses that syntax a lot, so get used to it. So you saw this on the for array, arrow, the arguments are taking off there, the block of the for loop. That's the same thing. Sequence generator up to whatever we need. But we can simplify that. In this case, this generates an anonymous closure on the fly, and the whatever we got is the first and second argument up to the whatever. Whatever we got, 0, 1 added together makes 1. The 1 and the 1 added together makes 2. The 1 and the 2 added together, blah, blah, blah. That is how that infinite Fibonacci sequence is generated very simply. And this is the sort of stuff which scares people. It scared me when I first saw it. It took me a while to understand it. Once I did, it's like, oh, that's actually not hard. That's part of the language we're going to be learning about as we dive into it more, which we can't today, at least not with me. This is some of the stuff which kind of scares people when they see the Perl 6 enthusiasts talking about, Stefan earlier when he was talking about inline Perl 5 and stuff like that. It's like, that looked kind of scary to some folks. But day to day, it's wonderful stuff, but day to day, that's not what you're actually going to be using most of the time, or it's going to be abstracted away behind the scenes for you. The simple stuff, yeah, it's easy. So, yes?
One slide back, just want you to know that in CSS we have a term for that star plus star. It's been nicknamed the lobotomized owl symbol. It might frighten
Well, people who use CSS anyway are, never mind.
The language stuff, as you said, it's safer and better. How stable is the runtime? Because that's going to be a big decision.
What do you mean by how stable is the runtime? Stable has what?
Tell 5 daemons that run for over a year, don't leak memory, don't leak resources, keep working stably.
I cannot comment on that. I'm talking more about the usage, but anyone else?
I can't move to that if I can't trust that it'll keep running.
It gets more stable under use.
Awesome.
If you needed to run for a year, I probably wouldn't use Perl 6. Yes.
I saw the is SW for attributes and or is cached for function.
Mhm.
Are there new keywords?
Those are traits which you can apply to things which can modify their behavior. It does look a little strange because you can say class dog is mammal and the term is overloaded there. It might be a trait. It might be a parent class. So that's one thing you'll have to get used to. But traits are something you can just slap on stuff and it can modify how the behavior is. And in fact, you can open up the source code. Most of it's written in something called NQP, which is a little bit more dense, a little bit harder to understand, but you can actually read through them to see how they're implemented.
Could you write such traits in Perl code for your own debugging?
Yeah.
If I can actually correct that, traits are written in Perl 6.
Oh, it's not NQP. Ah, I apologize.
In fact, the entire core library is written in Perl 6.
Thank you. Do I have time for another question?
I have parse
Okay,
readings.
yes. Yes.
Do you do constraints over multiple variables?
Constraints over multiple variables?
Like I have a function squeeze that should take an array of numbers and make sure that all the numbers are between a lower and upper bound, but obviously the constraint is that the lower bound has to be less than the upper bound. And any parameter can refer to a previous parameter in the list.
So, but every successive one has to be greater than the prior one. Yeah, that shouldn't be a problem because right there I have the star plus star. I'm assuming it should be easy to put, star less than star, put a constraint and then modify it on the fly. Or when I'm going back to the where constraints, yeah, that shouldn't be hard. I don't know the exact syntax of throwing the exception on that, but that shouldn't be hard.
One point subset point limit is now limited to this class point. It's not visible outside the class point. Is that correct?
Yeah, what's the scoping on that?
Well, subset. The type, so it's probably an our star.
Okay, I've got
Types are, but
1 minute left, so I think that's. Does anyone have an easy question I can answer in 60 seconds or less? You have 55 seconds left.
Presumably there's a performance driver has been using rational numbers to represent numbers.
Yes.
Can you represent them as floating point performance in
You can. You can foresight. Just call it a real.
call it a num.
Call it a num.
Num
Okay.
is the floating point type. If you use any literal that has E0 on it, is automatic floating point. It will actually promote the floating point if the denominator exceeds 64 bits, because you don't usually the performance problems with rationals is that denominator blows out a lot, and so we chop it off at 64 bits, pretty large denominator. If it gets larger than that, we just flip it.
Okay. Thank you.